Okay, let's look at another way to add rational expressions. Because I have a trinomial here on the top, so I'm going to look at, well, if I do some factoring here, maybe I could do some canceling to simplify before I add the two items together. So on the top, I'm going to factor x plus 2, x plus 4. And on the bottom, I'm going to factor into x minus 5, x plus 4. And I can do some canceling at this point because this is a factor, this is a factor, this is a factor, this is a factor. These are alike, so they can cancel. So I've simplified, and I'm at x plus 2 over x minus 5. Now let's go back to the other one here. So this guy can factor into x minus 3, x minus 1. And this guy can factor into x plus 5, x minus 3. Notice again, I'm going to have something that cancels here. So now I'm going to have plus, and I've got an x minus 1 on the top and an x plus 5 on the bottom. So now I need to add these two, and I've simplified myself a lot from the very beginning. Least common denominator, x minus 5, x plus 5. And from a previous video, I'm going to be kind of doing the same thing here. I'm going to take my x plus 2, and I'm going to multiply it by what's missing from the least common denominator. So if I divide these two by this guy, my x minus 5s would cancel, and I'm left with my x plus 5. Plus sign from right here. And then I've got this x minus 1, and it's going to get multiplied by these two divided by this x plus 5 means the x plus 5's cancel, so I'm going to multiply that by my x minus 5. So I've got quite a bit of work to do here on the top. I'm going to FOIL x squared plus 7x plus 10, and I'm going to FOIL right here, and I'm going to get x squared minus 6x plus 5. And I'm still over my least common denominator, x minus 5, x plus 5. And I'm going to do some combining of like terms. I'm going to get 2x squared plus x plus 15 over x minus 5, x plus 5. And if I could do any more factoring on the top, I would certainly look at that, because I might get something on the top that once it factored, it reduced with the bottom. Now in this case we don't, so we're all finished.